All right, good morning, ladies and gentlemen. Today, me and Evan are going to be going over Maria Agnesi. She was considered one of the first female mathematicians of modern times, and she also had a few big accomplishments for a female mathematician, which we will be going over.
Part of anybody's personality and who they are is owes a big deal to what environment they grow up in. And Maria Agnesi was very lucky to grow up in a time, in the big scale of things, was very lucky to grow up in a time where philosophies were changing. It was during the Age of Enlightenment, where reason was more being the focus instead of religion and faith, and so this gave way to lots of new thinkers, including Isaac Newton, who was considered the father of calculus, and modern or classical physics. And we have a quick video just to kind of give a whole idea of what was going on there.
So keep in mind also at this time, I'm not sure, this video will probably touch on it, that the education of women was not highly valued. So as we go into some of her accomplishments, you can at least appreciate what she did for a female during this time period.
Hi, I'm Christina Hartman, and tonight on About.com we're looking at the European Enlightenment of the 18th century. The Enlightenment was a philosophical, cultural, and scientific movement born in the middle of the 18th century. First impulsed by philosophers such as Spinoza, Bayle, Newton, and Voltaire, it developed in France and then in all Europe. The word Enlightenment was first used by Immanuel Kant in his essay Was ist Aufklärung?
Hopefully we won't have too many technical issues.
Or what is enlightenment? The name of the movement is seen as a metaphor for the passage of obscurantism to a free mind enlightened by reason. The Enlightenment elevates the individual and his ability to think by himself. It defends the equality of all men and the right to exercise their freedom of thinking and acting. Thus, it strongly defends science and opposes the vast influence of the church.
Could you possibly drop the quality of the video?
Yeah, I can do that.
Maybe it'll load a little faster.
Accusing it of obscuring reason. It stands therefore against despots and absolute monarchy. But that does not mean most of its philosophers are Republicans. They often support a moderate monarchy. The new Enlightenment thinkers bore the idea that a public sphere and debate was at the heart of the movement. They would gather in coffee houses in Paris or in debating societies held in salons or academies. Some European monarchs supported the philosophers and welcomed them in their court. It was notably the case for the Empress Catherine II of Russia or Frederick the Great of Prussia. They were called the Enlightened despots. There are many important figures of the Enlightenment, including Jean-Jacques Rousseau, Montesquieu, and Diderot in France. With D'Alembert, Diderot published the first encyclopedia for sciences, arts, and crafts. That book continues to be a major symbol from that movement. It was read and distributed throughout Europe. John Locke and Newton were part of the main thinkers in England, whereas Wolff, Lessing, and Herder were main thinkers in Germany. The heritage of the Age of Enlightenment is vast. It's often said to have spurred the French Revolution. More generally, it promoted values of society that are still of primary importance today: democracy, freedom, tolerance, and reason. This was a glance at the Age of Enlightenment. For more information, you can visit About.com. Thanks for watching.
All right, so as you can see, as Evan touched on, this was a period that,
it kind of
improvement.
paved the way for the future in a number of ways, including the following era of the scientific revolution, and then it has also impacted our modern life, thusly in a lot of different ways. But it really, it kind of shows because ideas about everything are subject to change during this period, especially sciences and in part women, but that was still not one of the main, that would be like
Okay.
equality from when it still was
Yeah.
a good bit away. So, and arguably still farther.
Okay, so to get into Maria Agnesi a little bit, she was raised by Pietro Agnesi, who was a wealthy nobleman and mathematics professor. And although women's education was not valued at the time, she kind of grew up in a fortunate situation that her father was, professor of mathematics at the University of Bologna, and he gave her some of the finest tutors growing up. She was recognized as a child prodigy growing up, and as you can see from the video we just saw, there was plenty of debates going on about philosophical and mathematical issues. At age 9, here she was giving speeches to some of the more intellectual people of the day on women's rights, even philosophical issues. She didn't get into mathematics until a little bit later, around 13 or 14, which is still fairly young. But at age 9, she was still mainly focused on philosophical issues. And by the time she was 13, she spoke 5 different languages, which is really impressive. And at the age of 15, she was giving full-blown speeches to college professors, people such as that, on topics as mathematics and philosophy, which is really impressive. You think about it today, it'd be a 15-year-old giving a speech to somebody from like the University of Florida, a highly ranked person. That's pretty impressive. Next slide, please. Just progressing further into life, she was the oldest of 21 children, so she had a large family. One of her main responsibilities was to teach her younger siblings and the concepts of just all general education, but mainly math. And this led to one of her more important accomplishments, which was the publishment of Analytical Institutions. At the time, this book was kind of like a revolution in mathematics. It brought all the mathematical theory, all the breakthroughs that have happened at that point, and it brought them all into one book, which is something they didn't really have at that time. And that was really helpful to just general education. She was an honorary mathematics professor at the University of Bologna as well, until her father died in 1752. Once her father died, she gave up mathematics and really any type of education and focused on the poor, the homeless, and the sick. So when you consider all this, it's really quite impressive that the last 40 years of her life, she really didn't even mess with mathematics or any type of educational values, and she focused on the poor, homeless, and sick. And despite that, she still had a few accomplishments, which we'll cover on the next slide. This is just 3 of them, 3 of the main ones that she had. In 1738, which she would have been roughly 20 at that age, she published a collection of complex essays on natural science and philosophy called Propositiones Philosophicae, which I'm not sure if I pronounced that right, but at 20 years of age, that's still pretty impressive. And then we talked about the textbook, which is really like a breakthrough for education at the time. And perhaps what she's best known for is the Witch of Agnesi, which it got that name. It was a mistake in translation. It was supposed to be Curve of Agnesi, but when from being translated from Italian to English, they translated the word as witch, so it was just a mistake. Next slide. So Evan's going to go over the Witch of Agnesi.
So the Witch of Agnesi is it's a curve formed by first creating a circle centered at with the value of the radius above the origin, and with a tangent line the diameter length above the origin. And there's 2 ways of creating it. One by using the value of phi here and determining the distance to p from the origin and on the x-axis, and the height as well. And then the other way, though, is to just use relative terms of the radius. And sorry, I think that's about all I was having to say for that part. And you can see, as you're taking different values or make different secant lines along the radius from the origin, you're forming a curve that looks like this. This is only half the curve. But when you see it like this, its applications can be seen more. It hasn't had many applications until recently, you could have used it maybe for modeling a hill or a surface that was very similar, but only now recently studying with our technological nuances that have allowed us to study stuff at a smaller scale, we've been able to look at different types of waves, and this helps to model some of them as for some things, kind of the decay of waves, and for both light waves and sound waves, it's used especially for kind of what they call resonant circuits, or kind of electric tuning forks, which should be theoretically lossless, but there is loss, and this helps to find that.
Okay, so that basically wraps up our presentation. Here's our references. Is there any questions? Okay, well, thank you for your time.
Good job.